Take a look at this phone. At first glance, it looks like a normal Android device. I have WhatsApp, Instagram, even mobile games installed. But this is not Android, this is KDE Plasma Mobile running on postmarketOS. In other words, this is full Linux on a phone.
English is not my first language, so I use synthetic voice in my videos to make them easier to understand. Everything you will see in this video is based on my real experience.
In this video, I'm not doing a surface-level tour. I'm going to test it properly. Calling, daily usability, Android apps, battery behavior, and the actual limitations. Let's start with the basics. A phone is not usable if calling does not work, so I tested that first. Calling works. Audio is clear, no modem issues. That may sound simple, but modem support is one of the most common failure points in mobile Linux projects. So this is a strong start. Now let's talk about general usability. If you're coming from Android or iOS, this does not feel experimental. Gestures are responsive, app switching is smooth, animations are consistent, it behaves like a modern mobile system. The quick panel is well designed, notifications and quick toggles are accessible from a single panel. There's no unnecessary gesture complexity. When I rotate the phone, it shows a floating rotation button at the bottom. This rotates the phone like Android. Small detail but very practical. Connectivity works as expected. Wi-Fi is stable. Bluetooth works properly. I connected a Bluetooth mouse and it worked without lag or pairing issues. These are small things, but consistency builds trust in the system. Now let's look at resource usage. In idle condition, the system is using about 30% of RAM. That's not extremely optimized, but it's also not unstable. For a Wayland compositor, background services, and a full Linux stack, it's reasonable. The system feels stable under light use. Another important advantage here is the app ecosystem. This system comes with access to Flathub, which means you're not limited to a small mobile app store. Through Flatpak, you get thousands of Linux applications packaged in a distribution-independent way. Even though this is Alpine Linux, which uses musl instead of glibc, Flatpak bundles its own runtime. So applications that normally target Debian, Arch, or other glibc-based systems can still run here without modification. I installed Chromium, Podman, LocalSend, and even Visual Studio Code using Flatpak, so you're not locked into a restricted mobile environment. You have access to real desktop-class applications, and that changes what this device can realistically do. File sharing is one area where Linux feels refreshingly simple. I installed LocalSend. There is no account setup, no platform restriction. You open the app on both devices, and they instantly detect each other over local Wi-Fi. I transferred large files without any issue. It's direct, efficient, and predictable. This is the kind of functionality that should be standard everywhere. Now let's enable docking mode. This changes the experience significantly. The phone I'm using in this video does not support USB display output, but imagine this running on a device that supports external display, like a flagship Samsung DeX-capable phone. At that point, this would feel very close to a portable desktop setup. Applications open in floating, resizable windows. I can multitask properly, I can resize windows, and I can stack applications. At this point, it stops behaving like a phone. It behaves like a small Linux computer, and that's because it is. This system is based on Alpine Linux. The terminal is fully accessible. There are no restrictions. For example, I installed Docker directly using APK. Docker runs. That means this is not just a mobile operating system. It's a general-purpose Linux environment in your pocket. Now, I want to talk about something more serious. Visual Studio Code. I installed it through Flatpak. Normally, VS Code requires glibc. postmarketOS is based on musl, so technically, native compatibility is not straightforward. But Flatpak bundles its own runtime, so it runs without issues. Now here's the important part. I opened my actual Office project. This is a Python-based system that analyzes PPG data. Originally, I tried integrating the full processing pipeline inside a mobile app, but mobile applications could not handle the workload reliably, so I moved the heavy processing to a server. The mobile app simply calls the API. That's the standard compromise. But on this device, I ran the full Python processing locally with temporarily GUI. No API call, no external server, directly on the phone. As a developer, that changes how I look at this device. This is not just consuming applications. It's capable of real development workloads. Now let's talk about Android app support. I installed Waydroid, the vanilla version. No Google services and no Play Store, so I installed WhatsApp manually. And I set it up on camera in real time. I entered my phone number, waited for the OTP. The SMS came in, verification completed normally. No crashes, no strange errors, no network issues. After setup, the app worked normally for messaging. Received replies, media opened properly. This is important because it shows the Android container is not just booting. It's functioning properly with network access, telephony integration, and background services. If I didn't tell you this was running inside a Linux container, you wouldn't notice. From a user perspective, it behaves like Android. Now, to test hardware acceleration properly, I didn't just scroll through apps. I installed Angry Birds inside Waydroid, because games are a good way to test GPU acceleration. The game launched smoothly, animations were fluid, no frame drops, no visible rendering glitches, touch response was accurate. This tells me that Waydroid is not running in software rendering mode. Hardware acceleration is working. The GPU is being utilized properly. And that's critical because without GPU acceleration, Android apps would feel slow very quickly. So performance here is not just usable. It's genuinely stable. Now let's talk about battery again. At 4 p.m. the battery was 66%. After 12 hours idle, it dropped to 31%. That's around 35% drain. On Android, this same device drops around 20% overnight. So Linux consumes roughly 10 to 15% more in idle. But there's an important detail, and this is a 5-year-old phone. Battery health is already degraded. So the difference is noticeable but not extreme. It's not draining 50% overnight. It's roughly 10% worse than Android. That suggests optimization still needs work. But it's not catastrophic. For a development-focused device, it's acceptable. For a daily driver, it depends on your tolerance. Now let's talk about the camera. On this device, the camera is not just low quality, it's effectively broken. The app opens, but image output is unstable and not usable. I tested multiple camera applications. The result is the same. So for now, camera support on this device is not production ready. If camera functionality is important to you, this alone makes it unsuitable as a daily driver. However, I am currently testing a possible workaround. If I manage to stabilize it, I'll update the details in the description. So, can this replace Android? If you require a high-quality camera, banking application support, maximum battery efficiency, then not yet, but if you value full Linux access, unrestricted terminal, Docker on a phone, local development workflows, true multitasking, then this is one of the most complete mobile Linux experiences available today. And more importantly, it's no longer just an experiment. It's becoming usable. If you're interested in real mobile Linux testing, not surface-level reviews, subscribe. I'll continue pushing this system further and testing it properly